Have you ever stood at the beach, felt a wave splash against your lips, and immediately tasted salt? It's something most people experience without thinking much about it. The ocean is salty. It's one of those facts that feels completely obvious. But if you stop and think about it, it raises a strange question. Rainwater is fresh. Rivers are fresh. Lakes are usually fresh. So, how did the oceans end up filled with salt while rivers didn't? The answer begins with rain. Rainwater may seem perfectly clean, but chemically it's slightly acidic. As rain falls through the atmosphere, it absorbs small amounts of carbon dioxide, forming a weak carbonic acid. When this slightly acidic water lands on the ground, it slowly begins to break down rocks through a process known as chemical weathering. Over time, this weathering releases tiny amounts of minerals from rocks. These minerals include sodium, calcium, potassium, and magnesium. Once these minerals dissolve into water, they start moving across the landscape. Small streams carry them into larger rivers, and those rivers eventually flow toward the ocean. Even though river water looks clear and fresh, it actually contains very small amounts of dissolved salts, picked up from the soil and rocks it passes over. Every day, rivers around the world deliver millions of tons of dissolved minerals into the ocean. But something important happens once that water reaches the sea. The water itself doesn't stay there forever. Heat from the sun causes ocean water to evaporate, turning it into water vapor that rises into the atmosphere. This vapor later forms clouds and eventually falls again as rain, continuing the water cycle. The key detail is that when water evaporates, the salt does not go with it. Salt is left behind in the ocean. Over millions of years, this process has repeated itself again and again. Rivers continuously bring dissolved minerals from land, while evaporation removes fresh water. Slowly, the oceans have collected these salts like a giant natural storage basin. Rivers themselves don't become salty because they are constantly flowing. Water enters rivers through rainfall, groundwater, and melting snow, then continues moving downstream toward the sea. The dissolved minerals they carry simply pass through the river system on their way to the ocean. They don't stay in one place long enough to build up to high concentrations. The ocean, on the other hand, is the final destination for most surface water on Earth. Once minerals reach the ocean, there is nowhere else for them to go. Over hundreds of millions of years, this has allowed salt to gradually accumulate in seawater. But rivers are not the only source of ocean salt. Deep beneath the ocean floor, volcanic activity also contributes to the ocean's chemistry. Along large cracks in Earth's crust, called mid-ocean ridges, seawater seeps down into the ocean floor and is heated by magma below. As the water interacts with hot rocks, it dissolves additional minerals before rising back into the ocean through hydrothermal vents. These underwater vents release mineral-rich water that further adds to the ocean's salt content. If salt is constantly entering the ocean, you might wonder why the ocean hasn't become unbelievably salty by now. The reason is that salt is also removed through several natural processes. Many marine organisms use dissolved minerals from seawater to build shells and skeletons. When these organisms die, their remains sink to the ocean floor and become part of sedimentary rock, locking away minerals for long periods of time. As a result, the amount of salt entering the ocean and the amount being removed are roughly balanced, which keeps ocean salinity relatively stable. So, the next time you taste salt on the ocean breeze, remember that it's the result of an incredibly slow planetary process. Rain dissolving minerals from rocks, rivers carrying them to the sea, and evaporation leaving the salt behind. A quiet cycle that has been shaping Earth's oceans for hundreds of millions of years. Something that most people experience all the time, but rarely stop to notice.